Hello, my name is Ryan Paul. I'm a software engineer on the documentation product team at Stripe. I'm here today to talk about documentation as an application.
In this presentation, I'm going to describe some of the things that we learned at Stripe while building our next generation documentation platform. So, advancements in web technology make it possible for documentation to be more like an application rather than a traditional user manual. This means dynamically generating content that is contextually aware and tailored to the individual user. It means richer user interfaces, more sophisticated client-side interactivity, and tighter integration between documentation and the product. I want to break down what I mean by contextual awareness. So we can take what we know about the user and we can use that to customize the content. So for example, we can look at the user's geographic location and use that to highlight payment methods and APIs that are relevant to their region. Or we can look at what features are enabled in the user's account and use that to selectively hide or show content. We've even experimented a little bit with things like programmatically reordering the navigation sidebar to more prominently show users things that we think they will personally care about. All of these advancements bring many advantages, but they also introduce new technical challenges. Greater complexity means more engineering overhead, and greater interactivity means that documentation is more challenging to write and maintain. Documentation that functions like an application typically requires a development-centric authoring workflow, one that mirrors the process used to write and deploy code. That raises the barrier to entry and makes it harder for people to participate. Before I get into what we are doing to contend with those challenges at Stripe, I'd like to show a few examples from our documentation just to demonstrate some of the ways that we are making our content more like an application. When a user is logged into Stripe, we can display the user's own API test key in the code examples. So when the user copies and pastes the code into their own application, they don't even need to change that test key. We built an interactive integration tester that we can embed in our user guides. This walks the user through the steps of testing their code. And it actually checks on our API backend to make sure that the user's application was able to successfully perform each of the API calls. So another cool feature, we have these checklist pages. In these checklists, the state of the checkboxes persists in local storage so that the user can keep track of which steps they've already completed. In some cases, we can actually check the user's account settings and use that information to proactively toggle steps that we know they've already completed. So in this particular checklist, for example, we can look at their account and see if they have two-step authentication enabled, and if they do, we'll just automatically check it off for them. This one is an interactive wizard that walks the user through a number of prompts to help them determine if a particular new regulatory program impacts their business. So users find this format helpful because it breaks down the problem into more tractable chunks and it removes a lot of the underlying complexity. When you're navigating something complicated like this, it's just sometimes easier to understand if you only have to deal with it one question at a time. So another fun one, we've got some code examples that dynamically changed based on user input. In this particular example, we let the user choose the colors in the font family, and then we use those to dynamically generate the styling code that they can then copy and paste into their application. This particular screenshot is from our integration builder, which is an experimental new format that we're piloting for tutorials in our documentation. The integration builder walks the user through the steps of building an integration, and it highlights the code associated with each individual step. So this format was developed by one of my colleagues, and it's setting the new standard for interactivity in the Stripe documentation. We're getting a lot of positive feedback on it, and so we expect to adopt it more broadly in the future. What you're seeing here is live on our documentation website today, so you can go and visit and see this for yourself if you'd like to try it. So moving on, I'd like to talk about the project that we've undertaken to modernize our documentation platform. I'll show you how this new platform is helping us overcome some of the limitations that we face with our legacy system. So I think I'll start by briefly describing what our legacy documentation architecture looks like. The whole website is effectively a monolithic Ruby application with Sinatra-based routing. So this technically isn't Rails, but it's very much an artifact of the Rails era. Each piece of documentation is an application view that's written in Herb, which is a templating language that's popular in Ruby. And all of the user interface elements that we use inside of our content, like tab switchers and code snippet boxes and things of that nature, they're all implemented as Herb helper functions in Ruby. So because the documentation is quite literally an application, we can use arbitrarily complex Ruby logic wherever we want. And whenever we need custom functionality, we just write Ruby code inside of our Herb templates. So this is a really powerful paradigm, but when you're mixing code and content, it's really difficult to make this approach scale. We have hundreds of pieces of documentation, and many of them have one-off Ruby code that is specific to the page. The extensive use of one-off Ruby code poses technical challenges. Because the content is effectively code, it's subject to the same standards that we apply to engineering. Every content change goes through the same process that we use for code. So, if you want to preview your change, you have to spin up a development server. When you finish making the change, the PR goes through code review and CI build and deploy process. The complexity results in a really high barrier to entry that makes it challenging for people to contribute to the documentation. Due to the level of friction involved, people will often just file a JIRA ticket instead of updating the content on their own. So the developer-centric authoring workflow, it's initially very attractive to engineers, but it eventually becomes a bottleneck for content updates, and it reduces the number of people who are willing to self-serve, to go in and produce content changes on their own. Another big issue that we face with all of our arbitrary Ruby code is fragmentation. It's hard to make changes that span the entire documentation platform because we don't really know with any level of confidence how those individual changes will interact with all of the one-off Ruby code on individual pages. So there are just too many edge cases. It's very brittle. It's difficult to iterate quickly on new features. And any kind of large systemic change is very challenging to test and debug. So how do we end up this way? Well, I think it largely boils down to our priorities. See, at Stripe, we care very deeply about the quality of the user-facing experience, and we've treated that as kind of our North Star for documentation. But we haven't always made a comparable commitment to improving the technical underpinnings. So eventually, the accumulation of technical debt began to slow us down. We have really ambitious goals for the documentation user experience, but the state of our documentation platform is making it difficult for us to achieve our vision. So we needed to reboot our docs platform and move forward with a renewed focus covering both the user experience and the technical architecture. So I think this brings me to one of the most important things that we've learned about documentation at Stripe, and that is in order to deliver a truly cutting-edge user experience that pushes boundaries, we also have to innovate aggressively under the hood and make sure that our documentation platform is enabling us to move quickly. So to that end, we've established a dedicated docs product team. It's a cross-functional team that brings together people with varied backgrounds. So we've got design, engineering, and technical writing. And we're all working concurrently on documentation user experience, the authoring experience, and the underlying platform. We're treating those three pillars as part of a holistic docs platform. So now I'd like to talk about what that next generation docs platform looks like. We have a React front end, which is built on the same user interface component library that we use for the Stripe dashboard. We also have a new documentation authoring format, which is based on Markdown, but with some custom syntactic extensions. We still need to use Ruby code for some of our custom page logic, so we proxy requests through a Ruby service that passes variables into the new renderer. I'll talk next about our content authoring system, which is called Markdoc. This is something that we built in-house. So we chose Markdown because the ubiquity of the format offers certain network effects. Like it's familiar to most engineers and technical writers, and there's a pretty large ecosystem of existing tools and libraries that we can take advantage of. It's also a lot easier to read and to reason about than our old herb templates. But Markdown isn't perfect. It's got a number of downsides. It's not really an ideal format for the kind of complex structured content that we have in our documentation. It doesn't provide much control over styling and presentation, and of course it also doesn't have any of support for content reviews or custom page logic, the kinds of things that are more traditionally the realm of a templating language. So I think it's worth noting that these things I'm identifying here as shortcomings are also in some ways among Markdown's greatest strengths. The Markdown format became so ubiquitous because it's simple and it doesn't try to do everything. And so that's a big challenge for us. We really want to extend Markdown so that it meets our needs, but we also want to avoid compromising the simplicity and the readability that have made Markdown so successful. We also really wanted to get the code out of our content entirely, making it possible to express page logic like conditionals using an entirely declarative syntax. Machine readability is another key goal for us. We want to be able to treat our content like data. And finally, we want to integrate with React so that we can take advantage of React's component-based architecture to drive more interactivity and make front-end development more coherent. So when we were devising our custom syntax for Markdoc, we decided to add a small number of composable primitives in order to keep the surface area small. So ultimately, what that means is that we wanted to add fewer individual features, but we wanted to make it so that those features could be used together in really powerful ways. There are 3 features that we have added to Markdown. So annotations allow you to assign attributes to individual Markdown blocks. These are like conventional document nodes like headings, paragraphs, ordered lists, and so on. Tags are the name tags accept attributes and optionally enclose other content. So these function a little bit like HTML tags. And variables allow us to use externally provided values inside of our content. So that's all we've added to Markdown, but these 3 features have a fair amount of depth. All of the functionality that we need can be expressed declaratively with Markdoc tags. So that includes conditionals, flow control, partials, user interface controls, and so on. So like for a conditional statement, for example, we have a tag that's called if. So defining custom tags is easy. It requires very little code. We also make it easy to map a custom tag to a specific React component. We take advantage of existing Markdown conventions where possible so that content still ultimately looks like Markdown. We want to avoid a situation where everything becomes a tag and the documentation starts to look like XML. So we're trying to avoid that by leaning heavily into native Markdown constructs. So I don't want to get too far into the weeds discussing how to use Markdoc, but I thought it might be helpful to show an example. In this example here, I've highlighted the custom Markdoc syntax, and I've left conventional Markdown parts in gray. So you can see a conditional statement and a callout. There's also an annotation in the heading that adds an ID. So the delimiters used for tags are configurable. We picked the brace and the %sign because it didn't really collide with anything else in our content. I mentioned earlier that machine readability is a really important goal for us, and I'd like to expand on what that means. When we parse Markdoc content, we get an abstract syntax tree, an AST. That represents the structure and content of the document as a tree of nested objects. we can walk that tree programmatically and manipulate it in useful ways. So the AST makes it possible to do pretty advanced static analysis, validation, programmatic transformation, other things that are useful to us. We have a schema for our custom tags, and it defines what attributes they accept and what kind of content you can nest inside of each one. So our validator will enforce the schema and make sure that the content is always well formed. If we want to, for example, find all of the places where a variable is used, or build a tool that finds all the links and checks to make sure that they still work, we can take advantage of the AST to accomplish that. So decoupling code from our content restores a lot of the simplicity that we lost when we turned our documentation into an application. Because all of our page logic, like conditionals, are expressed declaratively, they're first-class citizens in the AST. In our legacy system, conditional content is expressed programmatically in Ruby, and so it can be an if statement, it can be a ternary, or any other formulation that you can use in the Ruby programming language. But in Markdoc, it has to be an if tag, and we always know what that is, and we can statically analyze it in the AST. So the general prescriptiveness of this approach ensures that everything is expressed consistently between docs. So the declarative nature of Markdoc, it's sort of a superpower. Instead of docs as code, we have docs as data. We have a clean and consistent format that gives us the power we need to build application-like user experiences, but without the complexity of having a lot of arbitrary Ruby logic strewn throughout our content. When we initially landed on this direction, it opened up a lot of doors for us. We can do a lot of things with it. We can parse documents and serialize the AST to JSON at build time, which reduces overhead and makes it easy to pass around the data, use it in a bunch of different ways without needing a parser. So this is cool because if we're building tools in different programming languages, they all just speak the like JSON representation of the AST. We don't need to use the parser everywhere. So we have YAML front matter that we put in our documentation. We use that for like page metadata, routing information, things of that nature. And we're also exposing that in the AST. So it goes everywhere that the content does. Ultimately, what we aspire to is to be able to filter and query our documentation as if it is a database. We can use this in many ways to improve the user-facing experience and to power our own tools to give us unique insights into our documentation, the content, the structure, how we're using functionality, and so on. So I'll talk next about how Markdoc is implemented. Markdoc is implemented in JavaScript. We built it on top of Markdown, which is an open source JavaScript library that does Markdown parsing. So Markdown is extensible and it's fully compliant with the Common Mark specification. For those of you who are unfamiliar with Common Mark, it's basically like a community-driven effort to standardize a common dialect of Markdown. By building on top of Markdown, Markdoc is it's a strict superset of Common Mark Markdown. So we built plugins for Markdown that incorporate all of our custom syntax. But we're only using Markdown for tokenization, which is the initial stage of the parsing process. We take the array of tokens that we get back from Markdown and we use that to build our Markdoc AST. So Markdoc also has its own rendering architecture, which is very powerful. And one of the benefits of having our own rendering system is that we can output our content basically however we want. We get a lot of flexibility. So in fact, I have a pretty great example of that right here. As some of you may have guessed, the slide deck was actually written in Markdoc. So I used an open source library called Spectacle.js, which is basically just like a collection of React components for building a slide deck. And I made some custom Markdoc tags that wrap the Spectacle.js components. So I can use those tags and I can render a Markdoc document to a slide deck. And as you'll see later, I can even take advantage of this to add interactive features to the slide deck. So I think next I want to briefly talk about some of the alternatives that we considered along the way. Building a new content format is no small undertaking, and we wanted to make sure that we were doing the right thing, so we evaluated a lot of alternatives before we committed to this path. When we first started exploring ways to improve our content authoring experience, one of the things that we looked at very closely was ASCII-Doc, which is a plain text format that is heavily influenced by DocBook. So ASCII-Doc, there are a few popular implementations out there. The one that we really like is called the ASCII Doctor. It gets a lot of things right, and it has a lot of the extensibility that we were looking for in a documentation format. But the downside of ASCII-Doc is that it's not as ubiquitous as Markdown, and it has some syntactic idiosyncrasies that our technical writers didn't like. As we got deeper into fleshing out our requirements, it became clear that when we were looking at particularly things like React integration, we were likely going to have to fork an ASCII-Doc implementation in order to get all of the functionality we wanted. And so eventually we determined that the amount of engineering resources that would require would ultimately match, if not exceed, what it would take to just roll our own thing on top of a Markdown parser. So another option that we considered was MDX, which is a Markdown-based format that lets you embed JSX blocks inside of Markdown content. So for those who are unfamiliar with JSX, it's basically React's templating system, which is JavaScript based. So MDX has started to get a following in the React ecosystem, and you frequently see it used in conjunction with some of the new React-based static site frameworks like Next.js and Gatsby. The problem we have with MDX is that it tightly couples JavaScript code with your content. So in a lot of ways, it's like a more modern take on the Herb and Ruby system that we started with. The approach makes a lot of sense for many projects, but it suffers from many of the same limitations that we face with our legacy system. So because JSX is effectively JavaScript, you end up using arbitrary code for things like conditionals and flow control. So another problem we have with MDX is that it treats the JSX blocks like insular islands. You can get a document ast from MDX, but in that ast, all of the JSX tags are just these like blocks of JavaScript content that you have to farm out to a transpiler. So the ast doesn't know when you have an opening and a closing tag. It doesn't know what the attributes are on those tags and so on. If you want to do static analysis on the tags, you need to operate on JavaScript code. So next I'd like to talk a little bit about Markdoc's React integration. Markdoc is designed to support multiple renderers. We currently have a plain HTML renderer and a React renderer. I also built an experimental Vue.js renderer as a proof of concept, but we don't really use or support that internally at present. A custom tag in Markdoc can be mapped to a React component and can pass through its attributes as React props. We can also render Markdown document nodes as React components. So you can pick a React component for things like paragraphs, for headings, for ordered lists, and so on. It's worth noting that Markdoc's regular HTML renderer works really well with standards-based web components. So you can get many of the same advantages as Markdoc's React renderer without having to use React. I've done some testing with lit-HTML web component framework, and it works really nicely with Markdoc's HTML renderer. So Markdoc variables can be resolved on the server at render or build time, or in the browser using state from the React application. This is a really exciting feature because it means that the content in our application or in our documentation is reactive, and it responds to changes in state like any React component. This opens the door for a lot of really interesting client-side interactivity. It's a really significant and powerful feature, so I want to show you an example of what it looks like in practice. This is a somewhat contrived example, but it gets the idea across. We have a counter in the page that displays state from the React application, a variable called counter, and we have a counter button tag that is bound to the variable and increments its value by 1 every time it's clicked. So I'll click that a few times so you can see. And this is actually working in the slide deck because the slide deck is a React application that was built with Markdoc. So the counter button tag is backed by a React component that's performing the logic. It's totally agnostic about your state management strategy. In this slide deck, I'm using React state hooks, but you could just as easily wire it up with Redux. What you're seeing here is fully declarative data binding in Markdoc. So why React? We use React extensively at Stripe. We use it in the Stripe dashboard, we use it in the API reference, and we use it for many of our internal tools. We have an internal React component framework and design pattern library that was originally created for the Stripe dashboard and is now used across many other parts of Stripe's ecosystem. We were able to adopt that same component library for the documentation, which has saved us a lot of time, and it also results in a more consistent user experience between various Stripe properties. So in the long run, one of the things that we're really excited about is blurring the boundaries between our documentation and the dashboard and the API reference. Being able to use the same components across all of those places will make it easier to embed functionality from one into another. So we have some ideas that we would like to pursue for embedding, for example, API reference functionality in the documentation. You might actually start to see some of that show up on our site this year. Using the same component framework across everything makes that kind of cross-pollination a lot easier for us. So although we've removed all of the Ruby code from our content, there's still a bunch of places where we need to use Stripe's internal Ruby APIs to perform some logic. So commonly, like a case where we use this is like looking at the settings in a user's account so that we can tailor the content to their needs, as in the case of, for example, the checklists I showed earlier. So we want to have this logic, but we want to avoid a situation where it exists as a bunch of like one-off Ruby code on individual documentation pages. So instead of one-offs, we're trying to generalize that Ruby logic into coherent functions that are grouped together in modules that we call contexts. Contexts are grouped topically, so we have one for products like billing, for checkout, and so on. The context returns a hash with variables that are all primitive types that can be serialized into JSON. And this creates a really clean and well-defined interface between Markdoc and our backend Ruby logic, because we're just passing in these objects that have these primitive type variables. So it also makes our custom Ruby logic a lot more testable. Each page of the documentation can declare in the YAML front matter what context it wants to consume. So when the page renders, we execute all of the context that it needs, and then we take the variables and we pass them into the Markdoc renderer. This particular part of our system is still evolving. We're considering some more sophisticated alternatives that might give us more capabilities. So for example, we're thinking a lot about maybe building a GraphQL layer on top of it or something of that nature. It would certainly lend itself to that. So in addition to context, we also have some like user session data and document metadata that we pass to Markdoc when we're rendering a document. This includes things like, for example, just like the user's preferred locale, the feature flags that are associated with the documentation page, things of that nature. We're exploring some interesting things that we can do with this, like ways to mock values for external data and put those mock values in the YAML front matter for testing and previewing. So you can, if you have like a variable that you're using in a document, you can change the value and see how it looks in different states. So that brings the presentation to an end. We recently finished deploying our new React-based front end, and right now we're working to convert all of our content from Herb to Markdoc. We're learning a lot along the way. So I think we will have a lot more to share about Markdoc in the future when we've finished that conversion process. Thank you for listening.
Hello, Ryan.
Hi.
Hi. So tons of questions. I think we'll just get started. I'm not sure if I read things correctly, but it seems like we've got some opinions out there about Markdown versus ASCII docs. So maybe there's a flame war going on in the background that we can address. I don't know. I thought we could start with the question from Mike Jang, who's asked, why not contribute to an existing tool for the flexibility that you're looking for since we already have too many variations on Markdown?
Yeah, so there are a lot of, I think, related questions here around why we chose the path we did instead of using something that exists. I think ultimately we did choose to use something that exists in the sense that we built on top of a very mature, robust open source Markdown parser in the form of Markdown it. Markdoc is it's largely a Markdown it plugin, at least on the parser end of it. So I think like we didn't want to roll everything from scratch, but in terms of like AsciiDoc and some of the other options that were out there, I think that was a real challenge for us. It's hard to articulate the reasons without getting into the full breadth of like requirements that we landed on for this project. And you know, the whole AsciiDoc Playmore thing makes me a little sad because I am actually a really big fan of AsciiDoc, and I think that people can see the obvious inspiration that I've taken from it. At a very early stage in this project, I advocated fiercely for it internally, and there were a lot of challenges that we had in building traction for it. But ultimately, the reason that we didn't go with AsciiDoc was because for some of the more advanced capabilities that we wanted, we would have had to fork it. And I think we didn't want to be in a position where we were maintaining a complete fork. And you know, it was just so close to what we wanted, but it didn't have some of the specific things, particularly to meet our requirements around localization. So one of the things that Markdoc does is we can chop up the content into localizable strings and things like that. And so we needed a lot of control over the structure of the ask in order to be able to do that. And then also around React, we needed a lot more control over the interface between the syntax and the renderer.
Finding the unmute button. Okay. Just, I think I'll get to a few Markdoc specific questions. Alex is asking where he can learn more about Markdoc because he's been Googling for it, but it sounds like he's not finding what you're talking about.
Yeah, so I saw that, and I saw some questions about whether this will be open source or if it's proprietary to Stripe. And so the answer is that today this is internal. But we think that the underlying concept here of declarative format and docs as data, it has a lot of power. And so we're thinking a lot about what we can do to make this available to the outside world and to make it something that other people can adopt and use. So we can't commit to anything today, but we're seriously considering our options here, particularly along the lines of open source. And I think that right now we still have a lot of content that we need to convert to this format. We're still at a very early stage of adopting it. And I think that we need to get further along with that process before we let it out into the world. Because I think that it's evolving very rapidly, and we're making a lot of changes based on the things that we're learning while we convert the content. So I think we'll be in a better position to have something that is friendly for other people to adopt outside of our organization when we're further along that process later in the year.
Yeah, that was a good question from Aiden about whether we're dealing with open source or proprietary here. Dan's got a question also specific to Markdoc. Are there any Markdoc limitations when rendering ahead of time for static sites versus rendering pages on the fly?
Yes. Okay. So I think I kind of glossed over this a little bit, but we have support for resolving variables on both the server or the client. So when you have that like interactive content in your Markdoc document, you can put like a decorator in front of the variable and specify that this is something that should be resolved on the client side in React in the browser. And so when you're pre-rendering everything to use it in a static site kind of model, you only get that kind of variable, all of the variable interpolation. So you can, as long as your data, you can do the server-side rendering, but only statically at build time. You can't do it at runtime, obviously, if you're pre-building your content. So like in cases where we're doing things like customizing the data or customizing the documentation to the needs of the specific merchant based on variables in their user account, that kind of thing, like in order to do that at runtime on the server, you would need to render the page on the server. So if you're pre-rendering it statically, you can do that kind of per user customization on the client, but not on the server. So that's the main trade-off there.
A question from Owen. He's asking, with through to React components, did you ever experience breakage and refactors were incompatible with content? And how would you guard against that?
Yeah, there are some challenges around this. With the way that Markdoc works is the tags are defined in a schema that specifies how it maps to the React component. And so that insulates us a little bit because we have the ability to change the underlying React component independently of those schemas. And as long as it assumes that the props coming in are the attributes that are defined in the tag schema, then it works out. We don't have that kind of breakage. But there are still some challenges around this if you're making more significant changes and the attributes are changing.
I'm going to skip a little bit, or skip when people are posting the questions, but Chen has asked a question about usability testing. If you've done usability testing, how did your users find such doc customization?
So generally, we have done extensive user research on specifically the integration builder, but also some of the other features that I showed earlier in the presentation. And I think that the take from users has overwhelmingly been positive. I think people like having customization. One of the challenges that comes up with it in practice, though, is what we refer to as the Heisendocs phenomenon. When you have documentation that is dynamic and can change, you have two different people looking at the same URL, they could be seeing different content. And so if they're like talking to each other about, oh, there was this thing I saw in the documentation, somebody else says, well, wait a minute, I don't see that. It can be very frustrating. Or if you're logged in and you're used to seeing something, but then you're browsing in a like a private browsing tab or in a browser where you're not logged in or something, then suddenly the documentation doesn't look the way that you remembered it. Those kinds of effects are very jarring. So I think that's the single biggest challenge that we face with that kind of user customization.
That is an amazing new word that we should all be using, Heisendocs. I've not heard of that yet.
It's like Heisenberg's uncertainty principle, right?
Like, I'm not sure if I've encountered it, but just given the state of things everywhere, probably. I'm going to also skip to a question that Kat's asked because we're talking about user feedback, and she's asked if you have started to look into the outcomes or success metrics with moving to the modern documentation architecture. She's got the question in the chat here. How are you getting validation?
Yeah, so very early still. I mean, we only very recently adopted this platform, so we have a long way to go before we can really see the impact. But there are some metrics that we look at. We have a CSAT, like a customer satisfaction widget on the documentation. So we allow people to say, was this page helpful, and then provide feedback, in the form of like a short text blurb, what they liked, what they didn't like. So we're looking at that and we're seeing how that data is changing. We're also looking at the way that people engage with the docs. One of the, I think, big challenges that people tend to have with the Stripe documentation is there's just such a huge breadth of content that people will open a million tabs, and they have this phenomenon where it's like they have to switch between all these tabs in order to like find the thing that they're looking for. And so that's a big problem we're trying to solve for. And so we're going to look and see like what people's sessions look like, and whether that particular challenge is something that we're starting to fix. We also have a lot of people who say like, this is all great, but I want to be able to see like more of a code-focused walkthrough. And that was the problem that the integration builder was trying to solve. So, I mean, we have all these channels that we get this feedback from, and we're looking to see if these like consistent recurring themes that we see in feedback evolve as a result of these changes. Particularly people who are like, I want to see how it all fits together. If that integration builder is making that less of a concern for people, if it addresses that need.
Just a quick check on the time. I think we have like 4-ish minutes before lunch officially begins. But let's keep going because we have a few more questions, or several more. I wanted to skip ahead to John's question about how you handle search in your docs, which I think Paul Logan is in this chat. Maybe he's got a talk coming up about search at Algolia, Slack. But anyway, I'll let you answer the question.
Yeah, I also saw a question in the other chat about whether we're using the Markdoc AST to power search, which is I think a good insight, because that's a direction that we would like to go. It's something that we've talked about. Right now, our search is Algolia based, and we basically scrape the rendered HTML. but we would like to be able to use our data-driven docs format to be able to do better search in the future.
Okay, maybe one or two more questions. Johnson had asked a question a little while ago. I think, I mean, it's a little bit different from what we have been talking about, but a lot of us are very curious about every single detail about how Stripe implements documentation. So Tom was asking about how many people Stripe has on the documentation between writers and tool developers.
So on the docs product team, I think that we have, gosh, I mean, we have, I think, 5 now. I have to look at our Slack channel. But yeah, so the docs product team, we have basically 3 of us who are like full-time engineers. We have an EM, and we have design resources and a technical writer who's mainly working on like IA and like the direction of the documentation, like overall site. Then in terms of technical writers, the number varies. I'm not on that team anymore, so I don't have direct engagement with them. But yeah, we have a fair number of technical writers. It's still, I think, a pretty small team relative to the overall size of our engineering org. So I think one of the things that we're looking at is trying to increase the amount of self-serve to get like product and engineering teams more engaged with content authoring, because the size of our technical writing team is not big enough for our technical writers to be able to carry the entire load themselves. They have to collaborate and work as editors and help facilitate that self-serve process.
Yeah. Okay. Sorry, that was a little bit awkward. I was just taking a note over here. I think we might pause here. I mean, I feel like people can keep asking questions in the chat, even if we turn our cameras off. But it is about time to start lunch. And I guess after lunch, we do have the unconference talk starting along with the rest of the talks for the day. So thank you for your talk, Ryan.
Thank you.